Good day, Sir Halim. Today we would like to present our assignment about pulse code modulation. Okay, first of all, I introduce my group members. Shazwan Hazmi bin SHAMSHIR, B0821100491, and myself, ROOBAKKANTHAN, anak lelaki JAYABALAN, B0821100389. PAAVEEINASH, anak lelaki M.RAMESH, B0821103006, and our two little angels, SITI NURHIDAYAH binti NADZARUDIN, B0821100395, and also NURUL RABIATUL ADAWIYAH binti FAROK FAHMI, B0821100254. As for the introduction, in this assignment, we were required to design a pulse code modulation signal and to plot the pulse code modulation signal by using MATLAB. Pulse code modulation is a method used to digitally represent sample analog signals. PCM techniques are used to be produce a series of number or digits in binary forms. Hence, this process is called digital modulation. The amplitude that at the particle time of the signal sample is indicated by the binary codes. It is the standard form of digital audio in computers, compact disc, digital telephony, and other digital audio applications. PCM stream have two basic properties that determines their fidelity to the original signals, the sample rate, the number of the time per second that samples are taken, and the bit depth, which determines the number of possible digital values that each samples can take. That's all from me from introduction. Next, I pass to my fellow friend, Shazwan.
Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Shazwan Hazmi bin SHAMSHIR. I will explain about example 1 and example 2. Okay, for the example 1, we have to show that the graphic in the figure 1, what we have to use, figure 2, what we have to use, and figure 3, what we have to use. Okay, for the figure 1, we have to subplot 211, and the X label is time, Y label is amplitude, and the title is analog signal. Okay, for the subplot 212, X label is also time, Y label is amplitude, and title is sample signal. And the frequency we have to use 3. For the input, for the input is Y, SN 1. Okay, for the R, the input is Y and N1. For the figure 2 and figure 3 is also same with the figure 1. That X label is time, Y label is amplitude, title is input signal. I will show you the output. Okay, this is figure 3. That is show the square signal. This one is encode signal and decode signal. That also the same output. This one is analog signal and sample signal. The signal is show the sine wave. For the example 2, we have to use same formula, but the formula different, a little bit different. We have to use S equals to sine C 2 pi times that show that original signal and receive signal using the compounding. Encode and decode is frequency 3. Figure 2 is also same with the figure 1, but the plot X is we have to use red and plot D1 is green. The H legend is same original signal and receive signal without compounding. This one is figure 2 that show the green one and the red one. Okay, for the red one is original signal. Green one is receive signal without compounding. That I have declared. The diagram is show same with square signal. Okay, for the figure 1 is the red and black. For the original one is sine wave is red, and the receive signal used compounding is black. They have same figure 2, but a little bit different about the point of X and the Y. Alright, that's all for my explanation. I will give to next present. Alright, thank you.
And hello, my name is Siti NURHIDAYAH binti NADZARUDIN. For question exercise 2, question 2. Generate a 2 kHz sinusoid with a peak-to-peak voltage of 2 volt and generate a quantized signal when n equal to 8 and n equal to 60 levels. Calculate signal to quantization noise ratio SQNR. The formula for SQNR is equal to 20 log 2 power of n, or 2 power of n is equal to n. When n equal to 8, n is equal to 3. So SQNR is 20 log of 2 power of 3 equal to 16.062 dB. When n equal to 16, n is equal to 4, so SQ and R is equal to 20 log 2 power of 4 equal to 24.082. For the program n equal to 8, we change time to 0 and 0.0001 and 0.001. For message signal, we change to sin C 2 times pi times 2000 times t. So n is equal to 8. So we change at E U E N code Cn equal to 8 and D U D E code E N equal to 8. So for PCM without compounding, E1 UN code X comma N and D1 UD code X1 comma N. So the output we get is this one for figure 1 and figure 2. So for N equal to 16, time is the same and message signal also same, but we change N equal to 16. So the output we get is this one. For figure 1, the output red line and that line is in the same. Figure 2 is also the same. That's all.
Assalamualaikum warahmatullahi wabarakatuh, and hi. My name is NURUL RABIATUL ADAWIYAH BINTI FAHMI with metric number B08211024. For exercise 3, we need to use the MATLAB Simulink for the question 1. We add the signal generator with the amplitude to 1 and the frequency to 1 Hz. And then for the pulse generator, we set the amplitude to 1 and the period to 0.1 seconds. For the uniform encoder, we set the peak to 1 and the beats to 3. And for the uniform decoder, we set the peak to 1 and the beats to 3. I'll show you the output for decoded signal. And this one is the output for the encoded signal. For this one, this is analog signal and sample signal. This one is the square signal. Okay, next we're moving to the other part of the question. We need to use the MATLAB Simulink for question 2. This one is for receive out signal using compounding, while this one is the receive signal without compounding. According to the question, we need to generate a quantized signal when n equal to 8 level, so the n will equal to 3, so the bits will equal to 3. And the same one for the uniform decoder, bits to 3. After we click run, we will get the output for the receive signal using compounding. Next, for without the compounding, we need to change the module settings to 250 of the factor, and then we set the stop time to the value of 3, and we will get the output receive signal without the compounding. Next, we are changing the n to 4 to the 4 bits because the n equal to 16. I will get the simulation for the output receive signal using compounding. And for the without compounding, we need to change it to the 4. I will get this output. This output is the receive signal without compounding. Okay, that's all for me. Thank you.
Okay, as for the last topic for the discussion and conclusion, I'm Paveen, M.RAMESH Madhavan. As for the discussion, a message can be encoded using pulse code modulation by turning it into binary bits. This is known as source code. We discovered that PCM is noise robust and can be processed digitally. High bits per sample can be used to remove the noise interface. The greater the SQ and R, the higher the signal quality to be received. PCM is exclusively utilized in the digital domain. It is never used in the analog domain. The AD converter is used to convert the continuous message signal to a digital number. As a result, each number reflects a quantity message signal level. Okay. Conclusion. In a nutshell, we are able to grasp one of the digital modulation technique. Using MATLAB, we were able to simulate the pulse of code modulation PCM signal and plot the pulse of code modulation PCM signal. That's all from our group. Thank you, sir.